All right, get ready, because today we're diving deep into some research
Oh, yeah.
that could completely change how we think about and use LLMs.
I think so.
You've brought us some really fascinating material today about AFLOW,
Mm-hmm.
which is a system designed to automatically generate those
Yeah.
complex instructions that really make LLMs sing.
Right.
And we call those agentic workflows.
That's it. Yep. Agentic workflows.
Uh-huh.
It's not just automation, though. It's about efficiency, too. Imagine being able to hand off like all that grunt work, all the design of workflows, and still leverage even smaller LLMs
Right.
to potentially outperform the big ones, like GPT-4, for example,
Wow.
just because the workflow itself is so much more clever.
Okay, so hold on. Let's back up for a second. We both know that LLMs are capable of some pretty amazing things.
Hmm.
But why is designing these workflows such a bottleneck?
Well, it's kind of like trying to write the perfect recipe for a dish you've never tasted. You can tweak ingredients and cooking times forever.
Yeah.
But finding that perfect combination takes a lot of experimentation. Defining workflows for LLMs is similar. You need to define each step precisely, and a small change can have a huge impact on the output.
Yeah.
Doing all that manually is time-consuming and requires deep expertise.
I see. So it sounds like AFLOW is stepping in to be our master chef, experimenting with different workflow recipes, if you will, to find the one that creates the tastiest results.
I like that.
How does it actually work?
Well, think of it like this. AFLOW represents workflows as code, giving it fine-grained control over how an LLM tackles a problem. Then it uses a technique called Monte Carlo Tree Search,
Okay.
or MCTS, to explore all sorts of potential workflow designs. MCTS is this powerful algorithm. It's inspired by game-playing AI. So systematically explores different options, learns from each attempt, and uses that knowledge to focus in on the best solutions.
So it's learning as it goes.
It is, absolutely.
So imagine AFLOW is playing a game, and each move represents adding or changing something in the workflow as it plays. AFLOW is tracking which moves lead to better outcomes, in this case, a more accurate and effective solution to whatever task we give it. Okay, so it's constantly refining its approach based on the feedback, getting better at designing workflows with every try. But what are these building blocks of these workflows? The research mentions operators. What exactly are those?
Yeah, so operators are essentially predefined little chunks of code that represent common actions in a workflow. Think of them like Lego bricks that AFLOW can assemble in different ways.
Okay.
One operator might tell the LLM to generate text. Another one might tell it to go back and review and revise its output.
Uh-huh.
And yet another might say, take multiple responses from the LLM and combine them to produce a more robust result.
So it's like a toolbox full of specialized tools that AFLOW can then mix and match to create the perfect workflow for a specific job.
Exactly.
This is starting to make a lot more sense. You mentioned earlier that AFLOW could actually enable smaller LLMs to outperform larger ones.
Yeah.
How does that work?
It's all about efficiency. A really cleverly designed workflow can guide the LLM through the problem-solving process in a really streamlined way, minimizing wasted effort and helping the LLM to focus.
Yeah.
It's limited resources on the most important steps. Imagine you're trying to navigate a complex maze.
Yeah.
You could wander around aimlessly hoping to find the exit, or you could follow a map that guides you directly to the goal. A well-designed workflow is like that map.
I love that analogy. So a smaller LLM with a highly efficient workflow can actually achieve better results than a larger LLM with a less effective workflow. That's amazing.
It is.
This could be a real game changer for smaller companies or research teams who just don't have the resources to work with these massive resource-intensive LLMs.
Absolutely. AFLOW could make cutting-edge AI capabilities accessible to a much wider range of users, potentially leading to a surge of innovation in fields that were previously limited by the cost and complexity of using those large LLMs.
Now let's talk about a specific example. You mentioned that AFLOW was tested on this Matteo V5 dataset, a collection of challenging math problems. What were some of the results?
Well, one of the most striking findings was that AFLOW-generated workflows consistently outperformed the workflows designed by human experts. In some cases, AFLOW was able to achieve accuracy rates that were significantly higher than anything achieved before, even with much larger LLMs.
Hold on. So you're telling me that this system can create workflows that are even better than what humans can come up with?
It seems that way.
That's both awesome and a little bit unnerving, right?
It is.
It makes you wonder what other tasks we could apply this to.
A lot.
Yeah.
And that's just the beginning.
Yeah.
What's even more intriguing is that the researchers tested AFLOW without giving it any predefined operators at all. They wanted to see if it could discover effective workflow structures on its own.
So they basically took away AFLOW's toolbox and said, figure it out yourself. What happened? Did it crash and burn?
No, not at all. Surprisingly, AFLOW was still able to find effective solutions. It even independently developed an operator that functioned very similarly to the ensemble operator that the human experts had designed.
So even without guidance, AFLOW figured out how to combine multiple responses from the LLM to improve accuracy. It's like it invented its own problem-solving strategy.
It's pretty incredible.
Yeah, mind-blowing. Before we get completely lost in AI wonderland, let's break down some of the key innovations in AFLOW in a way that's easy to understand. You mentioned soft mixed probability selection.
Yeah.
What does that even mean, and how does it contribute to AFLOW's success?
That's a great question. It's really key to understanding how AFLOW avoids getting stuck.
Okay.
Imagine you're exploring a new city. You could stick to the main tourist attractions. Or you could venture off the beaten path and discover these hidden gems. That's essentially what soft mixed probability selection allows AFLOW to do.
Oh.
It balances exploration of new possibilities with exploitation of what it already knows works well. This helps it to discover more innovative and effective workflows.
So it's like AFLOW has a sense of adventure. It's not afraid to take risks and explore unconventional approaches, which makes sense because it's trying to come up with novel solutions. But it also knows when to stick with a winning formula. That's pretty impressive.
It's a balancing act.
Yeah.
But this balance is crucial because it allows AFLOW to find truly optimal workflows rather than settling for solutions that are just good enough.
Yeah.
It's constantly pushing the boundaries, searching for that perfect combination of operators and parameters to unlock the LLM's full potential.
This is all incredibly fascinating, but I'm curious about the practical implications. What does this mean for the average person? If AFLOW becomes widely adopted, how could it actually impact our daily lives?
That's where it gets really interesting. Imagine a world where anyone can leverage AI to automate complex tasks, even if they don't know anything about programming or machine learning. AFLOW could be used to create personalized learning experiences for students, to develop new medical treatments, to optimize business processes, so much more.
So the possibilities are really endless.
I think so.
This is starting to sound like the kind of technology we see in science fiction movies. But unlike those movies, this is actually happening right now.
It is.
It's incredible to think that we're on the cusp of such a transformative shift in how we interact with AI.
It does have the potential to be a major turning point in the evolution of artificial intelligence. But with great power comes great responsibility, right? As we explore AFLOW's capabilities further, we need to be mindful of the ethical considerations and challenges that come with this level of automation. That's something we'll explore in the next part of our deep dive.
Absolutely. We've only just scratched the surface here, and there's still a lot more to unpack. But before we move on, I'd love to hear what stands out to you as the listener. What are your initial thoughts and reactions to what we've discussed so far? What are you curious about? Let us know, and we'll try to address those questions and aspects in more detail as we continue our exploration of AFLOW.
Before we jump into all the ethics of it all, I think it's important to address something that you, the listener, might be wondering about. We've been talking a lot about all this potential. But what about AFLOW's limitations? Is there anything it can't do?
Yeah, that's a great point. No system is perfect. So where does AFLOW fall short?
Well, one thing to keep in mind is AFLOW is primarily focused on reasoning tasks. So problems that have a clear right or wrong answer, like question answering, math problems, code generation. These are all tasks where you can easily measure performance.
I see. So tasks that have a built-in evaluation function.
Exactly.
Okay.
For those kinds of tasks, AFLOW really shines. But when it comes to more open-ended or subjective tasks, like writing a poem or composing music, it's harder to define what success even looks like. And AFLOW hasn't really been tested in those areas yet.
That makes sense. It's much harder to tell a system how to be creative.
Right. There's no clear-cut formula for a good poem.
Yeah.
Or a beautiful melody.
Exactly.
So AFLOW has shown some really remarkable results. But it's important to be realistic about its capabilities and its limitations.
I see. But the researchers are working on expanding those capabilities, right? What are some of the big challenges they're tackling?
Yeah, one of the biggest ones is improving AFLOW's efficiency. Right now, it could take quite a bit of time and computing power to generate these really complex workflows, especially for really challenging tasks.
So it's a bit like waiting for a gourmet meal to be prepared.
Yeah.
It takes time to create something truly exceptional.
That's a good analogy. Just like a chef might try to streamline their cooking process. The researchers are trying to optimize AFLOW's algorithms.
Yeah.
to speed things up. They're exploring ways to reduce the computational burden and make the workflow generation process much more efficient.
That makes sense. If AFLOW is going to be widely adopted, it's got to be practical for everyday use. What about the types of tasks it can handle? We talked about those operators, those building blocks of workflows. How much can AFLOW actually do with them?
Yeah, that's another area where there's room for improvement. Right now, AFLOW only has like a fairly limited set of predefined operators. It's like working with a basic set of Lego bricks. You could build some cool stuff, but your options are somewhat limited.
So the researchers are trying to give AFLOW a bigger Lego set?
Exactly.
Okay.
They're working on adding new operators that will allow AFLOW to handle a wider variety of tasks. They're also trying to let users define their own custom operators, which would make AFLOW even more flexible and powerful.
That would be incredible. Imagine creating your own specialized operators for very specific tasks, like having a customized toolkit for solving problems in your own field.
It would be very cool. And that brings up another really important challenge, which is making AFLOW more accessible to people who aren't necessarily experts in AI or coding. Right now, you need some technical knowledge to really use AFLOW effectively.
So it's kind of like having a powerful piece of machinery that requires specialized training to operate.
Right. The researchers are aware of this, and they're exploring ways to make AFLOW more user-friendly. They're working on intuitive interfaces and tools that would allow anyone to use AFLOW, regardless of their background.
That's really important if we want to see AFLOW's potential fully realized. It can't just be a tool for a select group of experts. It needs to be something that everyone can use. Let's get back to those ethical implications. As AFLOW gets more powerful and more widely used, what are some of the concerns we need to be thinking about?
That's a great question. And it's something that the entire AI community is really grappling with. As these systems get more sophisticated, we need to be very careful and mindful of potential biases, unintended consequences, and the potential for misuse.
So it's not just about making AFLOW more powerful and efficient. It's about making sure that it's used responsibly and ethically.
Exactly. One of the biggest concerns is bias. LLMs, including the ones that AFLOW works with, are trained on these massive data sets of text and code. These data sets can actually reflect existing biases in society, and if we're not careful, those biases can be amplified by the systems we create.
That's a very sobering thought. We need to make sure that AFLOW-generated workflows are fair and equitable, and that they don't perpetuate harmful stereotypes or discriminate against certain groups of people.
Exactly. And that requires a lot of careful consideration of the data used to train these systems, as well as ongoing monitoring and evaluation of the workflows themselves.
Another concern is the potential for unintended consequences. Even with the best of intentions, it's possible that AFLOW-generated workflows could have some unforeseen negative impacts.
That's right. It's like introducing a new species into an ecosystem. You can try to predict how it's going to interact with the environment, but there's always a chance of unexpected outcomes. So it's crucial to be aware of this and to have mechanisms in place to mitigate any potential harm.
So ongoing research and careful monitoring are essential. We can't just set these systems loose and hope for the best.
No. Absolutely not. And that brings up another important point, transparency. As these systems become more and more complex, it's harder to understand how they're making decisions. We need to make sure that AFLOW-generated workflows are transparent and explainable so we can understand the reasoning behind their actions.
Transparency is so important if we want people to trust these powerful AI systems. We need to be open and honest about how they work and what their limitations are.
Absolutely.
We need to make sure these systems benefit society as a whole.
I think so.
This is a really complex issue.
It is.
We've gone from talking about Lego bricks and gourmet meals to the ethics of potentially world-changing technology.
We have. It's a lot to take in.
It is. Before we get too caught up in all the potential risks and challenges, let's remind ourselves of the incredible opportunities here. Remember those remarkable results in the Math HLV5 dataset. That's just one example. But it really shows AFLOW's potential to change the way we approach problem solving in many, many fields.
It's true.
I mean, it's really inspiring to think about how this technology could be used to speed up scientific discovery, improve healthcare, and create more engaging learning experiences. And we've only just started to explore these possibilities. As AFLOW evolves, it's likely to unlock even more applications that we can't even imagine yet.
It's true. That's the beauty of this field. It's constantly pushing the boundaries.
Yeah.
And challenging our assumptions.
So this brings us to an interesting question for you, the listener. We've talked about how AFLOW could impact all these different fields, but what about your own area of interest or expertise? How could AFLOW be used to solve problems or create new opportunities in your world?
That's something to think about. We'd love to hear your thoughts. We'll be discussing your ideas in the next part of our deep dive, where we'll be looking at potential future applications and exploring how AFLOW could shape the world of tomorrow.
We've got a lot to think about with this AFLOW. What's really fascinating to me is that we're not just talking about like an AI tool, we're talking about AI that can design other AI. That's got to have some pretty big implications.
It does, some of which we can only speculate about at this point. We're really in uncharted territory here.
So let's start with something that you, the listener, brought up, the impact on jobs. Is this the beginning of the robot takeover, where AI starts designing itself out of our control?
I get where that concern is coming from, but I think it's a lot more nuanced than that. Remember how we talked about those really complex workflows? Designing those takes a lot of expertise. What AFLOW does is take over those really tedious, repetitive parts.
So instead of replacing humans, it's actually freeing them up to focus on those higher level tasks, the parts that require creativity and strategic thinking.
Exactly. Think of AFLOW as a really powerful tool, but it's still just a tool. It's up to us, the humans, to decide how to use it, what problems we want to solve with it, and what ethical guidelines need to be put in place.
Which brings us to another great point from our listeners, the need for transparency and explainability in these AI systems. If we're going to trust AFLOW to design these workflows for critical tasks, we have to be able to understand how it's making those decisions.
For sure. And the researchers are working on that. One approach is to develop visualization tools that allow us to see how AFLOW explores those different workflow designs. It's almost like peeking inside the mind of the system.
That would be pretty amazing. Imagine being able to see how AFLOW weighs different options, how it learns from its mistakes, and how it arrives at a solution. It would not only help us trust the system more, but also give us some insights into how we can improve our own problem-solving strategies.
Definitely. Another interesting area is the development of explainable AI, or XAI. The goal here is to build AI systems that can give us clear explanations for the decisions they make.
So instead of just spitting out an answer, the system would tell us why it came up with that answer.
Exactly.
That would be incredibly valuable.
It would. Imagine a doctor using an AFLOW workflow to help diagnose a patient. The system wouldn't just provide the diagnosis, it also explained the reasoning behind it, citing medical literature and highlighting the factors that led to its decision.
That's a fantastic example. It really highlights how important collaboration is between humans and AI. It's not about one replacing the other. It's about figuring out how to use both to get the best outcome.
Right. And that's what AFLOW represents. A step towards a future where AI empowers humans to solve complex challenges that we couldn't have imagined before.
It's exciting and a little bit daunting at the same time. We're on the edge of a whole new era of AI, where these systems are just becoming so much more sophisticated.
Absolutely.
It's a time of huge opportunity, but it's also a time to be careful and thoughtful. We have to approach these new developments responsibly and make sure that we're using AI for the benefit of everyone. Well, we've covered a lot in this deep dive, from the technical side of AFLOW to the bigger picture of what it means for society.
We have.
But the conversation definitely doesn't end here.
This is only the beginning.
AI is always evolving, and it's going to keep bringing up new questions and new challenges, and of course, new possibilities.
For sure.
And we as a society need to stay engaged in this conversation and make sure that we're shaping the future of AI in a way that reflects our values.
I think so.
So we encourage you, the listener, to keep learning about this incredible field, stay curious, and stay engaged, because ultimately the future of AI is in all of our hands. Thanks for joining us for this deep dive. Until next time.